Hello, this is a short tutorial of how to use Blender to create 3D models. First, we can use the mouse middle button to move the camera around the center. We can also use Shift plus middle button to pan in a space. Let's start with adding mesh to our space. We can click the Add button on the upper left corner or use the shortcut Shift plus A. We can create many different basic shapes, for example, a cube. As you can see, there are arrows, and we can drag the arrows to move the cube along the X and Y, Z axis. We can use S for scale to scale the cube, and R for rotate. We can also use G for grab to grab this cube freely to move it freely in the 3D space. Let's add another shape. Shift A, then we can add a cylinder. Then, as you can see, I can click on the shape to select different shapes, but I can also use the upper right panel, which shows all the elements that are present in the current space. And the bottom right panel shows the basic properties of the current mesh, for example, location or the rotation. Then, how we're gonna change the shape even more. So we can, for example, we can choose the cube, click tab to go into modeling interface, and we can see there are some vertices and edges that describe this cube. We can grab one of the vertex and use G, remember G for grab, to grab the vertex around. However, this is not usually what we want to do because this is not smooth. Then we can use the proportional editing. Once we have that turned on, when you drag something, you can see a gray circle. Basically what it means that anything within the range will move proportionally with the vertex or the vertices that you're grabbing. Now, as you can see that when I grab this vertex, the other vertices are moving proportionally with it. And also, don't forget that in modeling mode, you always want to turn on the X-ray. As you can see, if we have that turned off, you will not be able to see the vertices blocked by the solids. And those are the basic controls that you can do with shapes to create 3D models. There's other powerful tools such as sculpting, which allows more personalized and stylish editing of the shapes, but we don't really need them. We don't really have to use them to create 3D models. Even with the basic tools that I have just showed you, we can still create, I still managed to create a fairly complicated ant 3D model, which will be used in our group's ant simulation. But of course, we're not gonna use the ant simulation, the ant model right now. We're gonna use something more simple, such as a ball, to represent the ants.
Creation inside of Unity. Once you've loaded into the hub, you can download any of the editors you'd like. We'll be using 3.47. Inside of projects, we can create a new project. We'll be using 3D built-in render pipeline. I've already created this project. You can label my project 6. We can go ahead and see what's inside of Unity. We can create a plane that will represent the material our ants can climb on. You can see this plane was, we can center the plane, and we can also apply scale to the plane to make it larger. We could zoom in with our mouse and as well as zoom out, and hold right click to rotate our view of the plane, or our view of the world. And then we could also grab objects in this world with their axes in order to manipulate their position. So we can go ahead and create some food pellets. For our tutorial, the food pellets will be cubes. However, we do plan on adding more complicated geometric representations. We can rotate our food pellets. We can go ahead and select it and copy it on this right side to create new food pellets. Create one more. this one we can put higher onto the scene. As you can see, these food pellets are floating in air, so we can use Unity's built-in physics engine and select physics rigid body, so these components will fall. We can also add a capsule to represent the ant's home. In this case, it will be a pill. Go ahead and apply a scale of 2 for everything to make it slightly larger. Here, our camera in the background is viewing the scene. We can manipulate the camera as well as apply some rotations to get a better view of the scene. Go ahead and move it in. Lastly, we can add some effects like particle system that will be used to render our ants. In this case, it's just basic fireworks setup. Lastly, we can add a ball that the user can use to control. Here's the ball. We can also make this one rigid body. So we go ahead and play the simulation. Have all the collision pre-built in for us.
Procedurally generate a mesh and how to manipulate the particle system in Unity. For the mesh, we created an empty object and named it wall. We added 3 components to it: a mesh filter. A mesh filter takes in a mesh and passes it into a mesh renderer. Mesh renderer just renders the mesh given the material. And then we created a script called mesh generator that will procedurally generate the mesh for us. Within the script, we have a few members. Namely, the lat and long segments will define how many vertices we want along the lat and long. The radius will say how large the mesh, how large we want the sphere to be. It's a mesh object is an array of vectors that represent the vertices, an array of indices that represents the triangles, where each index is the index of a vertex in vertices. Let's start, we create the mesh object and allocate the mesh in mesh filter, the mesh object that we created. Then we'll call create shape that will procedurally generate the vertices and triangles that we define our mesh to be. In this case, we are creating a circle. Then we'll call update mesh that will update the mesh that we have initialized with the vertices and triangles that we've created and recalculate their normals. Get nearest vertex index would then Get nearest vertex index is a helper function that we will later call that returns the index of the vertex closest to a position that's given into the function. For the particle system, we added a particle system, and then namely we initialize the start speed to be 0 as we will manipulate the particles on our own. And we made the simulation space to be the world so that the coordinate system that we're using is the world coordinate system. Right. In particular, we added a script called ant movement that would manipulate the movement of the particles to be what we determine would be simulating ant movements. Within the ant movement class, particle system. This is the particle system that we are manipulating. This is the mesh that we created. This is the mesh generator of the mesh, and this is the vertex, and this is a list of vertices, of vector vertices that we keep. Let's start. We will get the mesh objects, the mesh generator, and the vertices of that mesh. And then to update the position of the particles, what we do is we take the position of the particle and then we add a random direction vector that is normalized and multiplied to the speed that we determine it to be. And then we find the vector vertex that is closest to that position, and we allocate the particle's position to be at that position. We then update all particles to have these positions that we just calculated, and this is the simulation result that we get.
How we can represent the ant colony with a particle system on a sphere. Let's return to a more basic setup to demonstrate how ants interact with their environment, food cubes, and other ants. For the final project, there will be a global data structure that contains information like environments, food resources, where it is, obstacles, and all the agents. And any of the ant agent would be able to access a small portion of the data based on their location. This tutorial, in order to mimic this condition, we will just let any of the ant agent to have access to the whole global information. Now let's take a look at the code. Global information that's being shared across all the particles in this case. We can see such examples as world mesh and the array of food list. In this case, the food lists are initially empty, and as any ant encounters a food, it will be updated to the global data structure. This is trying to mimic the pheromones trail behavior. At an example of a particular ant behavior, we will simulate food gathering. Food are represented as cubes, and then with the current set of rules how an ant would navigate, which my colleague Kai has already explained, the ant try to somehow interact with the environment. In this case, an example would be find their food. As ant discovers the food, it will collide with the food essentially, and this leads to a certain behavior. Here is implemented within our code under this function called onParticle collision. As you can see, the most important thing here is each of the object besides ant will have a specific tag, whether if it's food, nest, or killer. And each of the tag represents a specific behavior the ant would happen when it collides with it. So now let's look at animation of this. So as we can see, the ant is generated from the nest, and now when it's navigating to its food source slowly, it turns green when it sees it immediately. And for the food particle itself, they react by shrink. This is simulating a food downgrading behavior. Now let's walk through an example of how a user can interact with the simulation. The example is going to be controlling the ball we created, which for the ant simulation specifically can represent a disaster of rolling rock. So what we're going to do is after we create this C# script, I'm going to attach this specific script onto this surface asset like this. Now we can able to use this script to control the ball. So to look at this script specifically, there is two methods. There is a start method, which turning the ball into a rigid body allows for physics to be realized, as well as a update function that is able to essentially taking user input specifically and moving the ball left and right. When we are rolling the ball towards the actual object, we can see we can see that it has physics, and when it collides with, let's try this again, when it collides with the cube, it actually does have a modeling a physical feature in that sense. And then as well as when the ant come in contact with the ball, the ant turns red, and this ant is sensing a danger. Covered how we plan to implement some key features of the ant simulation, such as food gathering. This will conclude our tutorial. Hope this gives you an idea of what our final project is and how it would be implemented, as well as learn a couple things from our tutorial. Thank you very much.